something that's very common in the industry, what they call water wheel flow sensors, where tiny magnets are in an impeller, and as it spins by a Hall effect sensor, the pulses are analogous to water flow. The interesting thing with a lot of these sensors, Jennova's done tests that a lot of them we can remove the Hall effect sensor, put in our transducer, and immediately generate energy harvesting power. So this could have a lot of applications in the water industry. Very large water, smaller laboratory type water flow. Fundamental concepts are the impeller has magnet rotating by our sensor, and the pulses going through our sensor into our Jennova board create power amplification and conditioning and usable DC power. So you have water flow with Venturi, that there's a delta P. You have a sensor that you power with 24 volts or 4 to 20 milliamps, so you need a power source. You have to have conduit, you have to have, it's going into your PLC, you have to have modules that drive the sensor. And so there is power required to drive the sensor for Venturi, for ultrasonic, even for the flow wheels, they drive power 24 volt to the Hall effect sensor. They have talked about the difficulty of running conduit and cabling and sensor hookups to pumps going all the way over to where their relay panel is. And if they had a means of powering a wireless transmitter that could give them the same information without having to run all of this conduit, run all of this cabling, they would find that very desirable. Our energy harvester would allow them to not need any external source of power. We have even found that our transmitter board will transmit these pulses wirelessly to a remote sensor where the pulses can be picked up, so no cabling is needed to have the frequency of your water flow. That greatly reduces installation and materials. That's a very desirable aspect of what we do. Certain areas with the turbulence of the water flow through pipes, they actually use vibration sensors and measure the frequency. This would be in applications where there's fairly large amounts of flow, like water municipality or irrigation. There, the vibration of the water flow would potentially be enough to power our energy harvester and create usable DC power. Here again, all you require is the water flowing, which is what you need it to do, and now you have power to transmit your information where you need it to go. Water is almost as ubiquitous in industry as electricity, and this is in so many different industrial applications, from dye houses, municipal waterways, food processing plant, and here again where we're trying to monitor very carefully the resources that we use. Being able to have a very inexpensive way to do that and see where the water's going, how much you're using, would just be being good stewards of the resources that